Let's factor the pattern known as difference of squares. In section 9.3, you learned that the product of the binomials a plus b times a minus b always results in a squared minus b squared. Now we're going to flip that on its head. We're going to take an expression defined as a squared minus b squared, and we'll factor it into the format a plus b times a minus b. Let's begin with this example right here. With two terms, the only things I can do are look for a GCF and then attempt to factor it by difference of squares. I know I don't have a GCF here without a coefficient on the x squared, nor an x on the negative 81. So I want to make sure that each of these terms is a perfect square. If it's going to follow the a squared minus b squared format, x squared will say that it has an a value of x. And over here, the b value, since 81 is the square of 9, we'll say that the b value is 9. So in the format described above, this would be factored as x plus 9, x minus 9. Let's do two more examples. 4x squared minus 9. Now we have a coefficient in front of the x squared term. I'm going to look for a GCF. I still can't factor one out. However, both of these terms are still perfect squares. If we have 4x squared, the a value, I find by taking the square root of 4x squared, would be 2x. The b value, which is the square root of 9, is 3. So this is factorable as 2x plus 3, 2x minus 3. Last one. Let's factor 3x squared minus 75. I'm going to look for a GCF, and this time I can factor out a common factor of 3. If I take out 3 from 3x squared, I'm left with x squared. If I take out 3 from negative 75, I have minus 25. But we're not done yet. We have to look at what's inside the parentheses and say x squared minus 25. That is an example of our difference of squares pattern. So now that you've seen a couple examples, you should see that this factors as 3 times x plus 5 times x minus 5.